Okay, we're very excited to inaugurate our new seminar room with a talk from our very own Valeria Paiva on network math for beginners.
It is lovely to see you all in the new room. It's gorgeous new room. It's great. So thanks, Kevin, for doing this and recording everything. And I wanted to start by saying that, yeah, it's network for mathematics for beginners, but it's not because you guys are beginners. It's because we, the guys in the joint work, are all beginners, okay? And as Kevin was saying, it's a cast of 1,000 because, well, because there's lots of different people working together for this. Oh dear. I thought I should have checked that business of moving forward. Okay, so I wanted to start by saying that this is my it's my answer to this business of our motto, and we might as well remind ourselves of our motto or mission, or while we're at it, right? We shape technology for public benefit by advancing sciences of connection and integration. And so my way of thinking about sciences of connection and integration, apart from category theory, is actually the idea that mathematics should be much more accessible to all. And this is one of the ways that I think we can try to foster this business of accessibility that that we kind of been talking about from the beginning. So my outline is just that. I'm going to have one slide about networked mathematics in general. Then I'm going to talk to.
Interrupt you for just
Are you okay?
Dan is having trouble hearing you.
Oh, sorry about that.
Yeah, I think. Oh, I hadn't switched the audio to the owl.
Sorry.
And maybe try talking a little bit more, Valeria.
Sure. So I want to start by talking about networked mathematics. Can you hear now? Is it better or?
I can hear it. It's just not a very good quality.
I'm sorry. I can try to. It's now the maximum that my computer, the audio on my computer, so I can't make it.
Go ahead, Valeria. I might fiddle a little bit.
Yes, please. Yes, please, Kevin. Fiddle with the machines.
But you can continue meanwhile.
Okay. So I want to kind of start by talking just one slide about networked mathematics. Then I wanted to describe 3 different research prototypes that I kind of been talking to on and off, kind of in the corridor. That those prototypes are Parmesan with Jacob and Sub at NIST. Another smaller prototype is MathAnnotator with Professor Larry Moss and his students, Pavel and Bert Gould. And then I want to talk a little bit about MathGloss with Lucy Horowitz. And then I want to discuss a little bit about what's next. So, starting from networked mathematics, I hope you recognize the picture. This is one of our first blog posts. And this blog post kind of, Brandon was saying very neatly and nicely that we want to make math accessible to everyone, students, mathematicians, scientists, interested people, etc. And that actually making it accessible just does not just mean putting it up in the web. So it's not just having signs at the door. It's actually making easy for people to find the door, putting ramps, making things as easy to use as possible, which is something else that Xiaowei also kind of has been going on about, the business of needing good UIs and stuff like that. And what I said kind of in 2021, in July 2021, is that we should be making use of the incredibly fast improving NLP tools. And we kind of should start by extracting math concepts from text and linking them to an ontology, and building up a math knowledge graph that should also be useful for formalization of mathematics. And as you know, kind of next year, we are having this Hausdorff Institute of Mathematics, where we want to connect the stuff that we are doing with math and NLP to actually formalize mathematics. And kind of I wanted to show you a little bit of something that we think it's kind of it's a very minor thing, but we hope it's useful. So let's kind of get going. I think you've seen this before, and my theory is that when you read mathematics that you're not familiar with, you mentally go around putting little circles, red circles around the things that you don't know what they mean. And you just kind of read for the gist of the information. So, kind of say, oh, yeah, this guy's going to define a torso, and it needs to do this torso in an inverse semigroup, and based on semigroup actions, blah, blah, blah. And you kind of collect somehow these notions that you are missing, and then you go and try to find them. But at the same time, you're thinking about the line of the argument. You're thinking what the person is trying to do with these words, and with what you already know are concepts that you don't know. And one of the main things of this whole idea of networked mathematics is that we want to allow people to create personal index of things to check automatically and as much as possible on the fly. And feel free to ask questions or to disagree with something if you feel like it. All good. And so kind of in 2021, we started thinking about that. And we already knew that there were kind of lots of NLP tools that we could use off the shelf. But you also knew that there's an awful lot of hype in AI, in particularly in AI for NLP. So we kind of were worried about how much of the stuff that could be used could we actually prove worked the way it should work. So we kind of, as I was saying early on, we wanted to just track these mathematical concepts and link them to a reasonable math ontology. And we kind of decided very early on that this reasonable mathematical ontology should be weak data. And the reasons for that are more sociological than mathematical. I mean, Wikipedia has a very reasonable portal of mathematical concepts, and I reckon at least that that Wikidata has a much better chance to being around for a long time than some of the other projects that are trying to do similar things. Wikipedia has been the 6th biggest site in the internet for more than 20 years now, I think, or getting to 20 years. And hence, I think they have more of a chance to carry on being around. I mean, for people who don't know, there was a problem with Freebase that lots of people contributed to. And then when Google bought it, it stopped being everyone's knowledge, and the info was never kind of put back into the public commons, as it were. So weak data was a decision that we took a while back. And then we kind of said to ourselves, well, what do the linguists have at the moment for extracting math concepts? And the linguists have a collection of things that could be used. So they have terminology extraction, which should be good for identifying fundamental mathematical concepts. But the idea of a terminology extraction tends to be transformed into tasks in AI, and the tasks some of the tasks kind of are overlapping. So there's one called named entity recognition, which is similar, but it tends to be used mostly for things like names of people, names of places, and names of organizations. So that's not the kind of thing that we want to extract, right? We want to extract mathematical concepts. But some people do do call these things named entities, because certainly, a big theorem like the Oneida lemma is an entity that is named. So we could think about it as named entity recognition. Some other people call it keyword extraction. And in AI and NLP, people try to use lots of acronyms. So it's NER for named entity recognition, KE for keyword extraction, or even definition extraction, DE. All these things kind of are overlapping tasks, and people have put lots of effort into producing software for these tasks. But there's no ATE for automated term extraction system dedicated for mathematics. And more disturbing, the generic automatic term extractors don't seem to work very well for mathematical text. The reason for that is kind of fairly obvious, right? I mean, most of the term extraction software that's being created has been created from text in newspapers and in the web. And if you think about the amount of mathematics in the web, it's good that we have lots of mathematics on the web, but compared to the rest of the web, it's very tiny indeed. So most of the things, most of the automatic term extractors work well for newspaper text, not for our kind of text. And that was the conclusion of the first of the preprints that I have with, in this case, with Brandon and Jacob and Sub. That was in 22. Now, as I was saying, the main problem that we have, I mean, it's not that we can't use the tools that the NLP guys produced for our text. We can. That's the thing works for any sort of text, including mathematical text, including things that have LaTeX and formulas inside it. But what's problematic is that we don't have baselines and we don't have golden data sets. So we cannot prove that what we're doing is how well whatever we're doing is working. So there's no, as far as I know, no human annotated or golden data set standard, the gold standard data set for math concepts. The best that we can do at the moment was a competition that happened in 2017, so quite a while back. And that one was on scientific concepts. But they only produced a very small data set, only 500 abstracts, 100 on NLP, 100 on physics, 100 on material science. So science that use mathematics, but nothing, the kinds of mathematics that we are mostly interested in, because of course, we are mostly interested in doing category theory for a collection of reasons. One of them being the fact that that's what we do at Topos in some ways, but also because we think that since category theory is an organizing tool for mathematics, it would be good to have category theory kind of fairly well analyzed using those linguistic tools that we are trying to produce. And then we kind of try to use what we called silver sets instead of golden sets. And the results were really not good enough. They were very low, around 20–25% instead of the 75–80 that we expected in some ways. And you can see this video if you want for Jacob explaining all the experiments that we did to show that the results were very low and what we then decided to do. But so because it was so difficult to prove that the terms that we were extracting were good mathematical terms, we kind of with Parmesan, with this first three-pronged part of the tools that we have, we decided to take a different tackle. We decided to let users ask for concepts. Kevin, are you kind of up for me to change from the slides to a little demo?
Yeah, absolutely. I think it should be smooth, but I am standing ready if I need to flick around anything.
Please, yeah, stand there, kind of. Let's see if I can do it. Stop share and share again. Share screen, and what I want is the window that is this one, Parmesan. Yes, this one. And here, share. So, as I was saying, we had this difficulty finding, proving. I mean, are you guys seeing it? This is the Parmesan 02 small prototype. And I actually already put in closed category, but I can put something else if anyone wants to give me let me just say why I put closed category. Closed category is it's an easier one to add here because we know that we have an NLab page for that. And we know that in Wikidata, we have a single page for closed category. So if I put something like functor, yeah, that's a good one. It should, sorry, search. Go on. It's syncing, but you know, the thing about that, so functor, we have 3 different things in Wikidata. The second one is the one that we want, right? In category theory, a mapping between categories that preserves their structure. You have functor, a design pattern in pure functional programming, which is a good one too. You have the one that we want from an lab too. And we also have a different one that I think is perhaps the same or similar to the one in functional programming. But the thing that's kind of neat about Parmesan is that you actually not only you give the user, in this case, 2 different places to look up concepts in lab and Wikidata, but you also want to give the user ways to see the word used in different corpora. So we kind of have as a first corpora, the newest corpora for us is Tom Leinster's book, Basic Category Theory. And when you click on something, you know, like free and forgetful functors, you should, God willing, get to the bit of the text of Tom's text book on category theory, which, you know, which is describing forgetful functors between categories of the algebraic structures, blah, blah, blah. So with that, we say that this is good for education because, you know, you can see the notion of functor in this case in basic category theory. We can see it, where is it? Let's kind of close this, go away. You can see it in the NLab, and you can see the number of things that you have too. So, you know, in the NLab, we are not doing so good because instead of going directly to the page on functors, we're going straight into sure functor, and geometry of physics and stuff like that. We don't have a very good, we don't have very good heuristics for this to showing up the search results yet. It's one of the things that we're working on. But still, we can see it in a textbook, in the NLab, and you also can see it in more research mathematics, right? In TAC, the abstracts from the theory and applications of categories. So again, say you like the idea of star autonomous functor categories. Oops, no, this is, you should, with a bit, if my computer, yeah, my computer will help us. We get to Jeff Eager's paper on star autonomous functor categories. So this is the first prototype that I wanted to show you. And I think I have to stop sharing and go back to sharing to go back to the slides. So as I was saying, Parmesan, then this little thing does it let the users ask for concepts. So we don't have to kind of get all of them correct because we just expect that the guy who's asking will ask for a good thing. We do this entity linking, which is another one of these tasks that NLP guys like. And we do search collocation so that, we want to be able to serve all these possible notions of concepts to the human user. And we try to do it thinking from the perspective of the learner. That's the idea of putting easier stuff, middle stuff, and perhaps more advanced stuff. Kind of between TAC and lab, things are a little bit confused, but that's the idea. And it uses the latex XML converter from NIST and uses a very obvious way of dealing with language, which is spacey, kind of a free thing from a company that does NLP for other big companies. And then we try to show how good we could do on that. And we actually had what was the state of the art in 2019, which is this extractor called Jiggy. It's a neural net extractor. We had some old stuff, text rank and multi-word expressions toolkit from 2004 and 2012. And then we have the very recent stuff like expert PL and PL marker 2022. But as I was telling you guys, these things have been trained for science. So there's little transfer to mathematics. And I have some tables to show you if you want to see it. But and now more recently, we are also trying to start doing definition extraction using linguistic tools. And I already showed you the demo, but feel free to go there, complain about things that are not working and tell us about it. Because I did not know if I was going to be able to show you the real thing working, this is the picture with monoidal category in this case. And again, it's an older picture because as you can see, at that stage, we only had the NLab and TAC. We didn't have Tom's book yet, but now we do. Now, we have this problem. Even with this very recent neural network kind of things from 2022, the numbers are still not very good. And so we kind of said, well, let's try something different. Let's try to use generative AI. So let's try to use ChatGPT. And that's a totally different project. And this project is with the Indiana guys, is Professor Larry Moss. Because as I was saying, what we want is to make math more accessible. So we want to make sure that the concepts that we extract are as correct and as completely as possible. We want to have a kind of a word net for mathematics. And if we could do that, we could have, we could produce index for monographs, books, self-study very easily. And we could have different ways that people could interact with this thing. So of course, I'm doing prototypes and we kind of using just Tom's book and NLab and TAC, but once we get this thing going, we can go for lots of different stuff. We can get lots of different books, so long as the license is good. We can get lots of different systems that are already on the internet. On the other hand, the guys in Indiana also wanted to think a little bit about the limitations and opportunities of large language models. So we kind of started with ChatGPT, but now we are already doing some work with GPT-4 and some other things. Because the problem that I was mentioning to you about not being able to verify how good is what we are producing, it's not a problem of mathematics only, right? There's lots of other domains where you have exactly the same problem. This is one of the reasons why Sub is so interested in this project, because he wants to do it for kinds of engineering and for other sorts of design and stuff like that. But, Old English has a similar problem. In any case, we are kind of start building this math. We want to build this math knowledge graph. And eventually I want to do mathematical natural language inference, MathNLI, which is something that I talked to you in January of this year. So 10 months ago, I was talking about this other project, which is for mathematics is much harder because, as I was saying, we don't have the first things that we have for other texts normal texts that are fiction or kind of or even history or geography. We don't have the problems of the vocabulary that we have in mathematics, and also because, you know, in certain mathematical books, if you go from one line to the next line, you have to write 5 pages on the side, right? And so I don't want to do any of that. We want to do just the easy things, the things that are helpful for people who don't know much about mathematics yet. So we kind of want to do, and when we talk to the guys who do formalization of mathematics, which is one of the other things that we want to connect to, they normally kind of laugh a little bit and they say, "Oh, come on, Valeria, that's easy. You know, difficult is actually kind of producing the proofs themselves, kind of reading a proof and transforming it into proper semantics, into proper bits of formalized math is hard, but just finding the concepts, it should be that simple." It should, but it's not totally simple. And we have some traditional issues of terminologies and some sorts of conventions that you have to decide for. So of course, if you shouldn't have plurals when you're trying to think about concepts, right? So you don't want to have pre-sheaves and pre-sheaf. You want to choose the singular and go for it. And mostly when people are doing ontological work, they don't want to have adjectives without a noun, even if the thing that is actually most mathematical about the sentence is just an adjective, like two categorical case, two categorical setting, or something like that. So in this case, when you have an adjective with a common English noun, you know, we don't want to think of it as a concept. We want to say that we'd rather lose this concept than invent something that's called a two-categorical case or two-categorical setting. And of course, if you have an adjective that's related to a noun or verb, you might want to try to canonicalize, and instead of having interpolated function, interpolate or interpolation, choose only one. But this is not very good either. You'd rather have distractive thing. You want to have whatever the text is giving you, because you don't want to second guess more than you need to. So when you have constructions, and so when you have, you know, this, when I showed you the first bit, you know, when you look initially at a piece of mathematics, you think you know which things are concepts and which things are not, but deciding to try to have a golden data set of that is not so easy. And you have to make lots of decisions to get guidelines that human mathematicians can follow. So, you know, the other thing is, because we want to do that to help people understand mathematics that they don't know about, we don't want to say that a sheaf of germs of analytic functions is the concept that I'm going to index. I think I want to, if I'm kind of trying to make it sensible for a learner, I want to separate the sheaf, the germs, and the analytic functions, because all of these three are different concepts that the person has to know in order to put them together to make a bigger concept. So you want to go for atomic concepts if you can. And so these are our guidelines, and this is a contribution in the NLP area, because, you know, you do want to treat math concepts as black box as possible. You want to use singular. You don't want to think about terms like theorem, corollary, paper, conjecture as concepts, even if, you know, it is a convention. You could want to have that if you're thinking about reading papers in logic. Then, you know, a theorem is an important concept somehow, but perhaps, or proof. But we think of these terms for category theory as being meta level somehow. They're about the writing of the paper, not the concepts, the mathematical concepts that we want to deal with. And of course, mathematicians are not mathematical concepts, even if some indexes in books do kind of list them out. We don't want, also we don't want acronyms and stuff, because different books will have different notation for different things. And so we avoid prepositions inside the concepts. And if a long span is a concept, and span is how the neural network people think about detecting these expressions, right? It's a long span is a concept. You want to add the important subspans to make it more accessible again. So we then bring ChatGPT to do that, to read the TAC abstracts and then NLab entries that we have already processed. And that is thanks so much to Evan, because he was the one who did the first scraping of the things. We asked people and everything, but Evan did the first scraping. And so in this second prototype, and I'm getting late, but in the second prototype, we want to use ChatGPT instead of an ATE system and see how it compares to the previous attempt. And we use sanitized sentences. That means sentences of a medium length and with no LaTeX after, using the LaTeX XML of Miller. And this is a little bit more complicated than it might look, because you don't want to just take anything between $signs and remove it, because the sentence stops making sense. So you need to remove it, leaving enough ideas of what the LaTeX was, so that you can parse the sentences. They still make sense. But Bruce Miller at NIST has been working on that for more than 10 years. So we can just use his stuff and works mostly okay. And out of 3,200 sentences in TAC, we kind of find 400 satisfying these constraints. Right, the other thing is the constraint of being not too small, not too big, is because when they are too small, it's because the parser made something wrong, so thought that just a Roman numeral was a sentence. When you say someone says, I want to prove I, in parentheses, blah, 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 2I, they make this sort of mistakes still. Even in 2023, the parser still makes some of those mistakes. So we don't want too short sentences or too long sentences. And we find enough, we reckon, for our purposes. So out of the 15,000 entries in the NLab in 2020, we get 180,000 sentences, more or less, and 55,000 of them satisfy the constraints. And we run some experiments. So we wanted to have 3 experiments, one with 100 sentences, which is our pilot experiment, to see that we could get to some decent guidelines. Then we had this 436 sentences from TAC that we thought would be a medium size thing. And then we wanted to do the 55,000 from the NLab. And it gets to be too long, too big. And we had, for the first one, for the pilot 100, we had 3 mathematicians checking every sentence out. And ChatGPT is our 4th annotator, because we thought at that stage that ChatGPT was good enough to be a perhaps slightly dumb human, but as good as a human. And as you'll see in a minute, that was a little bit too optimistic.
Valeria, you're talking about ChatGPT or GPT-4? Are you distinguishing between them?
I am distinguishing between them, and in this experiment, it's ChatGPT.
I see. Okay.
And more recently, there's things that has not been written. And this thing is an archive preprint, David, so you can look at all the details. But the stuff that we are doing now, which hasn't been written yet. I mean, we tried to make a submission and didn't get it, but that one is with GPT-4.
Okay, thanks.
Not all. Okay, so the prompts are the ones you expect. This is the initial one before the pilot 100 sentence. Then this kind of got, and this is what it really does at the moment. So you kind of, you give more instructions to ChatGPT. You say things like, be sure to make the concepts word singular. So for example, when you see functors in the sentence, you should extract functor rather than functors, and blah, blah, blah. And then you give an example in context. You don't have to give many examples, but I think we give something like 4 or 6 or something like that. And we kind of give some extra bits that we think are not, I mean, because originally ChatGPT was extracting lots of things like future work, main result, and stuff like that. So we kind of, conclusions, stuff like that. So we kind of gave some examples of things that it shouldn't be producing. And so that's the updated prompt template. And then this is what we used for our experiments. And not only ChatGPT makes mistakes, but the human annotators make lots of mistakes too. And they're minor mistakes that another human looking at it would say, well, this is, you know, we're not disagreeing. It's just that this person forgotten to remove the plural here, or it's just that someone used the capital because it was the beginning of the sentence and they just copied and paste from the text or something like that. So we needed to have an NLI annotation tool, and we repurposed one that we had before, well, that they had before for doing natural language inference. And so that's the second thing. And I will kind of, I'm going to get to the end of the slides, and then I can show that one in the other prototype, because you know, what it does is, this is not something for users to look at. This is for annotators to look at and try to decide what are the concepts in this sentence. So this sentence is, this yields a quadratic algorithm deciding the quality of diagrams in a free double category. So ChatGPT produces the things, double category, free double category, quadratic algorithm, and the human then goes and either accepts or rejects and add things if they're missing. So it's a bit similar to what we had in July 2021, but ChatGPT does better than what we had in July 2021, quite a bit better, but not as good as I thought it was going to be doing. So the results of the experiments are, because still we don't have a proper golden data set, what we kind of could measure was agreement between annotators, and agreement between annotators is high, between, I mean, 7.9, 7.4 is pretty good agreement between annotators, but agreement with ChatGPT is very low. And so it's 0.5, which kind of, you know, it's kind of every 2 terms that ChatGPT suggests, only one is good. And so we kind of then used a trick that people in industry use, which is to just have ChatGPT and one human, and then some other human just adjudicates, kind of just checks what is being produced. And then we get a slightly better score, but still not good enough. So we showed that we have some problems of mathematical term extraction. We showed that inter-annotator disagreements are real, not just the silly things that I mentioned before. We provide some guidelines to standardize the process. We get this annotation tool to help the humans, and we kind of can produce a few best practice for prompts, but nothing terribly good. And we kind of try to discuss this business of whether ChatGPT could already be used as a 4th annotator, as if it was a human annotator, and we think it cannot as yet. And you know, just, I mean, I'm not going to go through this these things all together, but I want to just show you that, ChatGPT also produces hallucinations that are kind of actually reasonable hallucinations in some ways. So the thing that it produced here was this Dress-Miller theorem. And the sentence was something like, Dress and Miller proved a result such that blah, blah, blah. And, I think even a normal human that's not a mathematician might think that that meant that there was a Dress-Miller theorem. But we know that's not the case, right? Only very special results proved by Dress and Miller would become a Dress-Miller theorem. There's this business of notoriety and importance that makes something become a theorem like so. So we need still to measure the quality of the large language models, and that's why we kind of carry on to those chat GPT-4, because while I started talking and now there's already another 2 archive papers improving the large language models. But one thing is true, the large language models are very easy to use and they give acceptable preliminary results. So it will be used. And we don't want people getting wrong results about mathematics and thinking that they got the right thing. So we have very first numbers, and hopefully we can build on this going forward. But now I want to finish with this, because that's the third one, the one that connects to the Hausdorff Institute of Mathematics program on formalized mathematics. And this is the small project with Lucy. Lucy is an undergrad student in maths department, the University of Chicago. And what we are doing together is this thing called MathGloss, which unifies glossaries of mathematics that we found already on the web. And I'm sorry, I just imported her slides, so they have lots more of information than we don't want. So she started by saying, well, what's a group? Then a group for Wikipedia is this, but before that you have to discuss the integers. Sorry. And then says, but for the NLab something very different, because it's a monoid in which every element has an inverse, blah, blah, blah. And so then according to Lean, that's what a group is. So what we kind of wanted to do, as she says, there are many resources, many audiences, and you want to see if people with different backgrounds can make sense of those collections of resources. So we want, with the project with Lucy, we want to improve communication between mathematician and computer. And the goals for that are slightly reduced in some ways, because we want to only organize the various resources for undergrad level mathematics, and we want to use this organization to make things more accessible and to bridge the language gap between natural math and formal math. And because Lucy is young and very disposed, she kind of says that the solution is MathGloss. So MathGloss is this table here, where we kind of connect words in English. So, I mean, I have told her that we should put a group after the abelian here, because it's an abelian group, and that we're talking, the concept here is an abelian group, and we kind of always relate them to weak data identifier, and we relate them to Lucy's undergrad notes on her mathematics degree in Chicago. We relate them, as I was saying, to the NLab. We relate them to Tim's multilingual dictionary, so that people that want to use a different language can use a dictionary that's been translated by humans, so it doesn't suffer from some of the problems of the things that happen in weak data. But the most interesting thing is this column here, which at that stage we are calling France UG, but I think we should call it UG to Lean 4, because what it does is that the same mapping that we saw a minute ago, mapping a group to the code in Lean that corresponds to a group. And this exists because the Lean guys, when we had Johan Kommelin come to Topos and talk about that, so this is in case I couldn't do the demo, if you click on the 0-1 law, it sends you directly, and I will show you in a minute, to this Kolmogorov's 0-1 law in Lean. Because as Johan told us when he came to talk to us, the Lean guys decided to try to see how far away they were from from having all the undergrad mathematics formalized. And so they took the French are much more regimented, so they have a standard for what a math degree should comprise. So they have a collection of things, and Lean kind of maps some of these things to the bits of code, as you can see here. So this is Lucy's explanation, long explanation about all the things that she did. So kind of the Chicago corpus is her own corpus. The French UG, as I was saying, are terms translated into English, but some concepts from the Ministère de l'Éducation nationale de la jeunesse. And the French then have 543 terms in total, and only 369 we mapped to weak data using a library that was created for Old English, for digital humanities stuff called Weak Mapper. And we also map the NLab, but the NLab, we have many more mappings than we put in the table because there's too many things that are more sophisticated, and we want things that are undergrad math. So we restrict the terms that are in the other corpora. And as I was saying, we end up with Tim's dictionary, which now is called Mulima, for multilingual mathematics. And she just put a picture here showing the English, the French, and the Japanese, but there's many more languages that you can check the boxes. And where else? Well, we can do this. That's the thing that I was saying. Whenever you can do one of these resources, you can do many others. And so we did TAC for that too, and we did the Wolfram Alpha Math World, but then we decided not to use it because the license business is always problematic. And when I was in DAG2 recently, we kind of I talked to other guys, to other interactive theory improvers, to try to ask them to produce resources like the ones that the Lean guys produce for us. So kind of, I'm hoping that they will do it. So, and that's my last slide. What's next? The 3 parallel projects are progressing. Each one has new milestones. I kind of, because of questions I said a few things about each one of them. More corpora would be nice. It still work. It is easy. It's off-the-shelf software, but needs doing it, and cleaning up things is always a bit of a pain. We are still producing the golden standards. That is part of the plan. That's the bit that's been trying to use the GPT-4 and hasn't worked quite yet, but we are working on that. And we need a knowledge graph big plan, kind of, and we want it as off the shelf as possible. And we also are advancing on the theory, kind of on the theory of when we have trivial inferences in mathematics, and in the theory of linguistic causality. And funding would be very helpful, but we don't have it yet. So some of the references are here, and if anyone wants to see how bad things are, even with the very recent neural term structures, so the PL marker and the SPERT PL. So these are the results, these are percentages, and are pretty good because these are in the science corpus, the benchmark, that's science. When we do that in TAC, which is not so good. We got around the 20% and similar on the lab things. But that's why we need to have proper annotated data sets, because tag keywords are not very good as a data set, as a golden, and lab not good at all. So, and I'm going to stop here to see if you guys want to ask questions. I can't hear anyone. I mean, I can't even hear claps. Is that?
That was a good talk. That's Xiaowei here.
Hang on, Xiaowei. Can my mic claims it's responding. You can't hear anything, Valeria?
Now I can. Now I can. Yeah,
Yeah, I'm not sure why the claps didn't project, but we clapped, I promise. Thank you. Question for Valeria. Did you have one, Xiaowei?
Yeah, maybe I can go first. So with GPT, turns out these days you could, if you have access to a small server, you could train your own small GPT. You could, for instance, take the existing math labels that you have, and then do a little bit of fine tuning. There's like a special method called QLoRa or something like that. Are you considering, like, trying to train GPT to be a little bit better at picking out math words?
We're certainly considering that, shall we? But as I kind of was saying just now, if you don't, when you have a project where people work just for the fun of it, you don't pay them, you can't tell them that you want them fine-tuning things, right? And my friends have not liked the idea so far. I'm a very persuasive person. I keep insisting. So eventually I'll get it fine-tuned on mathematical text. But I see the point, you can't, this is, I mean, it's getting easier to fine-tune things. So it's kind of, that's why I think I will succeed eventually. But I have been saying that for 2 years and I haven't been able to make headway on that.
I'm glad you've been thinking about it. Yeah, but this is not easy. Yeah, I know that this process of cleaning up data and everything is not easy. So great job, Valeria.
Thank you. No, I mean, I think it is interesting how, I mean, as you know, things are getting much more exciting about formalized mathematics. So I think that's one of the reasons why this thing is kind of getting more impulse. So, I now have people promising to kind of think about my problem of other mappings to Isabel and Koch. Fingers crossed they will do it and everything. I mean, because, what I want to do in this thing is to be the linguist, right? I don't want to be the person who does formalization. I don't do formalization of mathematics. If I were to do it, I don't know which system I would use. And, I don't want to think along those lines. I just want to help people find where the things are if they want to do it. And I think that is, for that, English is a good thing to be using. That's whenever a human mathematician talks to another human mathematician, especially if they are not writing or in a blackboard, they will use language. I mean, you're sitting on the pub, you use words, and you kind of say, oh, I have a space a bit like that and that. So it should help, I think.
Yeah, and I think the data sets is a great step forward, because if in future when researchers wanna who are actually good at the training of the neural networks or the formalization, because the data sets are all there, it make their job a lot easier.
Yeah, no, I mean, on that, don't get me started, because there is something called MathBird, and
right?
Yeah, you say to yourself, okay, that's what I need. I just kind of, instead of using plain BERT, I use MathBird, but the data is not available. You can use their MathBird, but you can't retrain because the data is not given to us. So, if you did use MathBird, you could not check the quality of this stuff because you don't have the raw data to look at its concepts and stuff. So AI is full of this kind of traps of kind of, you give people one bit, but not the bit that they want. It's just problematic.
Thanks, Valeria.
Thank you.
Dana?
Can you hear me, Valeria?
Yes, I can.
Okay. Some years ago, Oxford University Press made their whole catalog electronic.
Right.
Would a publisher like that be willing to collaborate on some kind of mining of the resources?
Dana, you probably know more about that than me, because I know that you were in a meeting in 2016, wasn't it, in the Fields Institute in Canada? I mean, that where Ingrid Debauches, or the famous mathematician was. They had lots of people discussing, but it was under the aegis of Wolfram, and I think lots of mathematicians did not like the idea that everything was kind of being thought in the direction of Wolfram Alpha and Mathematica. So I think, I mean,
that's not what I was thinking of. I was thinking that Oxford has electronic versions
they
of
all
their whole catalog.
they all have, Diana, but they're not going to give it to us.
Well, but maybe, I mean, we have a lot of connections with Oxford as an institution. I'm still counted as an editor there. Maybe they would collaborate on a project, not to give away things, but to, if there's a collaborative project, to use their database. So, they wouldn't be giving away anything, but if there were a project, they could make the database available for combing through. Yes.
Well, I wish I believe it, but I don't, because even this project that I mentioned this competition that I mentioned in 2017, which was paid by Elsevier, they only gave 500 abstracts. Everyone knows that 500 abstracts, you can't do anything with that, and still they didn't give the data as given. They let the researchers kind of use it for the competition, and that was it. So, the publishers are a terrible bunch. Kind of, it's very difficult to deal with them. And personally, I don't think I want to work with anything that they say that they will kind of give us access, because, then we end up in the same situation as I just mentioned to Xiaowei, this business of, you work with their data, you do things, and then, you can't show what you've done because they won't give you the ability to see the data. So I don't know. I mean, I hope that the mathematicians and the AMS and the guys will be able to push things somehow. I mean, even the archive that we think is completely free, has a complicated license that just now the guys in NIST managed to transform it all into a corpus, and they are doing that with a huge target, something on some banner on it saying, we are distributing this as fair use. We think this is fair use, but it is kind of debatable.
Investing the whole archive.
But thank you. Thanks for the suggestion. And and if you can tell them to at least give us the abstracts, because it's in their interest to give us the abstracts, right? If they give us the abstracts, more people will try to buy this stuff. But sorry, Kevin, go ahead.
No, you're still you. I just wanted to ask kind of what your vision is about a mathematical knowledge graph longer range, 10 years from now? Do you imagine a big graph of the entirety of all mathematical knowledge, kind of analogous to Lean's monorepo, or some kind of more process for building local knowledge graphs? Like what's the thing that you
Good question.
Going?
Very good question. I know what I don't want it to be like. I don't want to be like Freebase, right? Which disappeared. And I want it to be a little bit more like WordNet, which is still available for English, language. You have this big resource that works. I want it to be better than WordNet because I wanted it to be much more about reasoning with the concepts. And I don't know how much we'll get along those lines of having relationships, because you see, the stuff that we are saying in 2021 was that if we had the inferences between concepts, then we could do something that the material scientists and biologists have done to a certain extent, which is to look at developments of research and see bits that are missing. And we want to do that for mathematics. And the thing is, okay, if we had the right, if we followed Professor Scott's suggestion and gotten the correct connections and stuff, we could use their data to find some of these things. It's just unclear to me how much they would let us then give it away, right? And in the case of material science and stuff, people have been able to just say, oh, we can do it. And if you had the same connections that we have, and you've paid the same publishers the same amount of money that we paid, then you can do it too. That's the level that this thing happens.
Okay, let's thank our speaker again.
Thank you very much, for listening, and I'm really very excited about having more feedback from you guys. So if you please can play with the prototypes and tell me more, that would be great.
Yeah, thanks, Valeria. Those who are here in the physical dimensions, if you please step across the hall for cookies and tea, we can do that now. All right, thanks, Valeria. See you soon.
See ya. Bye.